Tranquility is the quality or state of being tranquil. That is, calm, serene, and worry-free. The word tranquility appears in numerous texts ranging from the religious writings of Buddhism, where the term passaddhi refers to tranquility of the body, thoughts and consciousness on the path to enlightenment, to an assortment of policy and planning guidance documents, where interpretation of the word is typically linked to engagement with the natural environment. Benefits: psychological. Being in a tranquil or a restorative unregistered trademark environment allows individuals to take respite from the periods of sustained directed attention unregistered trademark that characterize modern living. In developing their attention restoration theory, Kaplan and Kaplan propose that recovery from cognitive overload could most effectively be achieved by engaging with natural restorative environments that are away from daily distractions and have the extent and mystery that allows the imagination to wander, thereby enabling individuals to engage effortlessly with their surroundings. The theory works on the principle that the amount of reflection possible within such an environment depends upon the type of cognitive engagement, that is fascination, that the environment holds. A soft fascination unregistered trademark is deemed to occur when there is enough interest in the surroundings to hold attention but not so much that it compromises the ability to reflect. In essence, soft fascination, which has been taken by Herzog and Pheasant as a reasonable term to describe tranquility, provides a pleasing level of sensory input that involves no cognitive effort other than removing oneself from an overcrowded mental space. Enjoyment. For many, the chance to experience tranquility is what makes the countryside different from cities. In a survey by the United Kingdom Department for Environment, Food and Rural Affairs, 58% of people said that tranquility was the most positive feature of the countryside. Health. In contrast to a soft fascination unregistered trademark, a directed attention unregistered trademark requires a significant amount of cognitive effort, and it is known that prolonged periods of sustained mental activity can lead to directed attention fatigue. This condition has the potential to significantly affect performance and bring about negative emotions, irritability and decreased sensitivity to interpersonal cues. As the incidence of mental illness continues to rise, there is growing evidence that exposure to natural environments can make a significant contribution to health and well-being. Mounting evidence shows that exposure to nature contributes to physical and psychological well-being, such as the review carried out by LOAV, that found evidence of a nature deficit disorder unregistered trademark in children, which suggests that the importance of being able to engage with restorative environments applies across a wide age range. Others report that natural tranquil surroundings have profound physiological effects on people suffering from stress. For example, Ulrich found that stress, induced by showing videos of workplace injuries, improved significantly quicker following further viewing of videos included natural surroundings rather than busy traffic or shopping scenes. A recent study has demonstrated the benefits of simulating such environments for pain relief during bone marrow aspirate and biopsy. Economic. Since seeking tranquility is an important reason why many people visit the countryside, the presence of tranquil areas helps boost rural tourism. Since rural tourism in the UK directly supports 380,000 jobs and £13.8 billion annually to the economy, and a recent survey showed that tranquility is the main reason why 49% of visitors go or are attracted to the countryside, one can conclude that tranquility is worth 186,200 jobs and £6.76 billion a year to the economy. 3. Computer science. In computer science, tranquility is a status in which software entities must reside, before their implementation can be safely altered dynamically. Tranquility, as a status, was first introduced in 2006, by Vandwood and Ebret. They implemented tranquility on the level of software components. Tranquility research. Natural settings that effortlessly engage our attention are typically associated with soft fascination and with the analysis of tranquility and preference published by Herzog and Bosley. In this study, the authors attempted to distinguish empirically between the constructs of tranquility and preference as effective qualities of natural environments. motivated by ART, from which they took tranquility as a reasonable term to describe soft fascination. They produced definitions for each component. Tranquility they defined as a Euro how much you think this setting is a quiet, peaceful place, a good place to get away from everyday life via Euro, and preference as a Euro how much you like this setting for whatever reason Euro. Subjects were asked to score the following visual settings: mountains, deserts, fields/forests and waterscapes against the two target variables, tranquility and preference, and four descriptive variables, mistiness, unstructured openness, focus and surface calmness. Tranquility and preference were positively correlated across all settings, with tranquility scoring higher ratings in the field/forest, waterscape and mountain categories, whilst rushing water had the highest rating in the preference category. Analysis of the results identified three physical features that help explain the apparent split between tranquility and preference. These were mistiness, unstructured openness, which refers to how open the scene is and how difficult it is to establish a sense of depth or distance, and surface calmness. Mistiness and unstructured openness tended to depress preference relative to tranquility, whilst surface calmness tended to enhance it. Herzog and Barnes conducted a follow-up study in which deserts and waterscapes were included in the setting types. In 2000, Herzog and Chernick conducted further research into the tranquility construct when they investigated the relationship between tranquility and danger in urban and rural settings. The key results that emerged from this research were that a Euro setting carry a Euro unregistered trademark, which relates to how safe we feel in a particular setting, is more salient for judgments of danger in urban settings than natural ones, and that openness was a significant predictor of danger but not of tranquility. The authors concluded therefore that tranquility and danger should not simply be viewed as polar opposites, but like preference and tranquility as distinct constructs. The role of audio-visual interaction within the tranquility construct. Within tranquility studies, much of the emphasis has been placed on understanding the role of vision in the perception of natural environments, which is probably not surprising, considering that upon first viewing a scene its configurational coherence can be established with incredible speed. Indeed, scene information can be captured in a single glance and the gist of a scene determined in as little as 100 milliseconds. The speed of processing of complex natural images was tested by Thorpe al. Using color photographs of a wide range of animals, in their natural environments, mixed with distractors that included pictures of forests, mountains, lakes, buildings and fruit. During this experiment, subjects were shown an image for 20 milliseconds and asked to determine whether it contained an animal or not. The electrophysiological brain responses obtained in this study showed that a decision could be made within 150 milliseconds of the image being seen, indicating the speed at which cognitive visual processing occurs. However, audition, and in particular the individual components that collectively comprise the soundscape, a term coined by Schaeffer to describe the ever-present array of sounds that constitute the sonic environment, also significantly inform the various schemata used to characterize differing landscape types. This interpretation is supported by the auditory reaction times, which are 50 to 60 milliseconds faster than that of the visual modality. It is also known that sound can alter visual perception and that under certain conditions areas of the brain involved in processing auditory information can be activated in response to visual stimuli. Research conducted by Fezent et al. Has shown that when individuals make tranquility assessments based on a unimodal auditory or visual sensory input, they characterize the environment by drawing upon a number of key landscape and soundscape characteristics. For example, when making assessments in response to visual-only stimuli, the percentage of water, flora and geological features present within a scene, positively influence how tranquil a location is perceived to be. Likewise, when responding to unimodal auditory stimuli, the perceived loudness of biological sounds positively influences the perception of tranquility, whilst the perceived loudness of mechanical sounds have a negative effect. However, when presented with bimodal auditory visual stimuli, the individual soundscape and landscape components alone no longer influence the perception of tranquility. Rather, configurational coherence was provided by the percentage of natural and contextual features present within the scene and the equivalent continuous sound pressure level. Predicting tranquility researchers at the Bradford Center for Sustainable Environments have developed a methodology by which the perceived tranquility rating of an amenity area such as park, green or urban square can be measured, on a 0 to 10 scale. The method involves the assessment of average daytime noise levels LDAY and the measurement of the percentage of natural and contextual features NCF contained within the visual scene. The latter includes the percentage area in the visual scene occupied by natural features in the landscape such as vegetation, water and geological features, for example exposed rock outcrops, and contextual features. These contextual elements include listed buildings, religious and historic buildings, landmarks, monuments and elements of the landscape, such as traditional farm buildings, that directly contribute to the visual context of the natural environment. Lastly, the equation includes moderating factors that can influence the perception of tranquility in either a positive, or a negative way. TR equals 9.68 plus 0.041 NCF or Euro 0.146 LDAY plus MF. These moderating factors are not expected to be large, and because they are relatively difficult to quantify, they are the subject of ongoing research. One potentially effective solution to improving tranquility is to mask traffic noise or distract attention with an attractive water sound. A previous experiment has demonstrated that water-generated sounds have the potential to improve the perceived tranquility of gardens blighted by noise. A further study has demonstrated that litter has the potential to degrade an environment such that the tranquility rating drops on average by 1 scale point. This bimodal relationship is supported by work recently carried out by ScanLab at the University of Sheffield, using fMRI neuroimaging techniques. This study demonstrated for the first time the significant differences in effective connectivity between areas of the brain, namely the auditory cortex and the medial prefrontal cortex, under tranquil and non-tranquil conditions. Specifically, the medial prefrontal cortex receives significantly enhanced contributions from the auditory cortex when presented with a tranquil visual scene compared with non-tranquil visual stimuli. Mapping tranquility equals. The first method of mapping tranquility was developed by Simon Rendell of ASH Consulting for a Department of Transport study in 1991. This led to the production of a set of tranquil area maps covering England, produced by Rendell and ASH Consulting and published by the Campaign to Protect Rural England and the former Countryside Commission. In these maps, tranquil areas were defined as places sufficiently far from the visual or noise intrusion of development or traffic to be considered unspoiled by urban influences. More sophisticated mapping techniques are now available following work by researchers at Northumbria University, Newcastle University, and CPRE. Maps have been produced for the whole of England that show the tranquility score of Ordnance Survey grid-derived 500 x 500 m squares. The tranquility rating for these is based on 44 different factors that add to or detract from Euro unregistered trademark S feelings of tranquility. These factors were defined following extensive public consultations. The new methodology uses advanced modeling techniques to look at the diffusion of the impact of these factors over distance, taking into account the terrain of the land. For example, the tranquility increases gradually the further one is from a busy road, but increases more sharply if the road is hidden in a cutting. The mapping process was developed by Northumbria and Newcastle Universities. The dark green areas represent those with the highest composite tranquility score. Dark red areas have the lowest composite tranquility score. Stimuli with positive impacts on tranquility equals, a natural landscape, including woodland, presence of rivers, streams, lakes or the sea, birds and other wildlife, wide open spaces, clear open night sky with without moon, beach in a unique location, open field, floor etc. with gentle to moderate wind flow. Examples of stimuli having negative impacts on tranquility equals, motorized transport, cars, motorcycle, trains and aircraft and roads and railways, light pollution, large numbers of people, pylons, power lines, Masts and wind turbines, noise. Note: this cartographic study showed that tranquility is not the absence of all noise, activity and buildings. Indeed, it found that many rural activities, such as farming and hiking, and natural noises such as birdsong and cows lowing, enhance Euro unregistered trademark S experience of tranquility. See also, ataraxia, passaddhi, upekkha. Notes: original figures from the Rural Strategy 2004, DEFRA. References